In this video we will see another dynamic programming problem. So the problem is that we have to find the number of ways to score R runs in B balls. For example, we have 3 balls and we have to score 4 runs, and it's given that you can score either 0, 1, 2, 3 or 4 runs in any ball. So any ball you play, you will either score 0, 1, 2 or 3 or 4. So let's see all the scenarios. So our initial state is that we are required to find 3 balls, 4 runs. So one case is that we scored 0 run. So this case. Then we will be left with one less delivery, one less ball, but the same number of runs, 2, 4. If we score 1 run, then we will be left with 2 balls and 3 runs. Similarly, if we score 2, we will be left with 2, 2. If we score 3 runs, then we are left with 2, 1. And if we score 4 runs, we are left with 2, 0. And now recursively, these will again simplify to next 5 steps. So it will be 1, 1, 4, then 1, 3, then 1, 2, 1, 1 and 1, 0. And this will be 1, 3, 1, 2, 1, 1, 1, 0, and we will get negative. So base case would be that if we have negative runs, then we can ignore that. So we will stop when any of these values become 0. And from 2 2 it will be 1 2, 1 1, 1 0. And from 2 1, 1 1, 1 0. And from 2 0 it's already 0, and so on. So here also we will see why it comes under dynamic programming. One, it's being called recursively. So if this function calls f34, then f34 depends on f24, f23, f22, f21 and so on. So it recursively calls itself and breaks the problem into subproblems. And we have overlaps also, like here we need 1 3, here also we need 1 3. So the entire tree below this will be same for this. And again here we have 1 2, and here also we have 1 2, 1 1, 1 1, 1 1, 1 1. So there are too many overlapping subproblems. So it's very important to store the values. Once we calculate these, we don't need to recalculate them. So we will store those values, and so that's why it falls under the paradigm of dynamic programming. So let's write a recursive relationship. So we have f of uh, B balls and R runs. So this is equal to, we will list down all the possibilities. So the ball will decrease by 1, so run can decrease by 0, plus number of ways to score. So if we score 1, this is that case. Then if we score 2 runs, then it will be R minus 2, plus 3 runs case, R minus 3, and then finally when we score 4 runs. So this is the recursive relationship of BR with respect to its lower order terms. So now how can we solve this problem? So let's see the example for 3 balls and 4 runs case. So if we have 0 ball 0 run, there is one way we don't play. If we have 0 balls but greater than 0 runs, so this is ball, this is run. In that case we have 0 way because we have some run to score but we don't have any balls left. So there is no way, so it will be 0. On the other hand, if we have some balls left but we have no runs, then we will just play dot balls. That is 0 0 in the remaining balls. Like here, uh, if we have 3 balls and 4 runs, then we can score either 4 in the first ball, then play the next 2 balls 0 0. So here, after 1 ball, we had already scored 4 runs, so we had to score 0 runs in 2 balls, so we will score 0 0. Then we can have 0 0 4, then 0 4 0. So this is 3 way. Then we can have 1 0 3, 1 3 0 and 0 1 3. Then we can have 1 1 2, 1 2 1, 2 1 1, again 3. Then we can have uh, 0 2 2. So 2 0 2 and 2 2 0. And what else we can have? Uh, so we got 12. Is there anything else? Uh, so here, yeah, it will be 0 3 1, 3 1 0 and 3 0 1. So this 1 and 3 and 0 will have 6 ways. So we have 3 ways, 6 way, 3 3. So total we have 15 ways. So the answer for this 3 balls 4 runs is 15. Now let's solve this using DP. So we will draw a table. So this side will be balls 0 1 2 3 and this side runs 1 2 3 4. So we don't need this part of the table. So this is 1 and this side we have runs. So if we have to score 0 runs, there is only one way. We will play only dot balls, that is we will score 0 in every ball. If we have 0 balls left and runs more than 0, then we will have 0 way. Now to calculate the value of other cells, let's see this relationship, this recursive relationship. So this BR depends on 5 values. So every coordinate corresponds to a cell in the table. So if this row is B, this row is R, then to calculate this BR, it depends on B minus 1, that is this row, B minus 1 R, that is same column, then B minus 1 R minus 1, so this column, B minus 1 R minus 2, B minus 1 R minus 3, B minus 1 R minus 4. So to calculate this cell's value, we will pick 5 cells of the previous row, starting immediately from above this. So for calculating this, we will add this and this. We have only 2 cells, so we cannot go till 5. Maximum we can take 5, but we have only 2 cells here, so just add this 1 and 0. For this again, these three, that is 1. For this also 1, for this also 1. Now for this we will add these two. For this, these 3. For this, 4. For this we will add all these 5. Now we have 3, then 3 plus 3 is 6, then 6 plus 4 10, and then here all the 5, that is 15. And this is our answer because we want 3 balls and 4 runs. So this table returns F3 4 is equal to 15. So now let's write the code for this. Count ways. So here B denotes number of balls and R denotes number of runs, and we can score either 0. So we take the size of the table to be one extra row and one extra column because we have to account for that 0 0 case also. So now we will fill the base case. So if runs is 0, then we will put 1. So if j is equal to 0, then I is the ball. So if number of balls is 0, then we will put 0. So let's initialize this with 0, then add all the 5 cases. I minus 1 j, this is when we score 0 runs. And then the case of 1 run, 2 runs, 3 runs, and 4 runs. So these are the only possibilities. So this I will decrease by 1 every time because we have to play that ball. So number of balls will decrease. Here the number of runs will decrease by 1. Here the number of runs will decrease by 2, then 3 and 4. And for this case we need So j should be greater than equal to 1. Here 2, then 3, then 4. And then finally we can go ahead and return. So first is B, then R. Now let's try this code on our example. Let's comment out earlier problems. 3 balls and 4 runs. It should print 15 if there is no mistake in the code. So it printed 11. That means there is some mistake here. 3 balls, 4 runs. Okay, so let's add this check if I is greater than equal to 1, because everywhere we are using I minus 1s. Now let's see what it prints. Again it's 11, so something else is wrong. B is the ball and runs. I denotes balls. Okay, so here it should be B and R. Okay, now it should, I guess, print 15. Yes, so now it's working correctly. That was a mistake. So this is a very simple code, and whatever I described there. So to calculate ij, we just need all the 5 cases. Like when we score 0 run, ball decreases by 1 but run remains same. When we score 1 run, both decrease by 1. Similarly for 2, runs decrease by 2 and ball by 1. Similarly for 3 and 4. So this is a very simple code, and I hope you understood how we are using dynamic programming here. So thanks for watching and give your feedbacks, and don't forget to subscribe my channel. Thank you.